When it comes to preheating printed circuit board assemblies at the benchtop, there are 4 distinct methods to do so. However, as you will see, not all preheaters are created equally. The 4 methods of preheating PC boards at the bench can be described as 1. The use of convection ovens, 2. The traditional use of hot plates, 3. The more recent use of infrared or IR grids, and 4. The most widely used method of all, that of bottom-side forced convection, also called a PCB air bath. The first preheating method is the oven. If there is an oven in close proximity to your bench, then the use of an oven to preheat your substrate during low-volume soldering or rework and repair, or even in prototyping, can yield uniform temperature profiles because an oven will warm both the top and the bottom of the PCB assembly, just as ovens in high-volume production equipment do, such as conveyor ovens or the popular wave solder machines. Since one cannot perform soldering and desoldering tasks while the PCB is heating inside the oven, the technician is required to transfer the hot PC board back to the bench, which is awkward and would require high-temperature gloves and other precautionary methods. Even more problematic, the PCB begins to cool the moment it is taken out of the oven. The obvious limitation to the hot plate is that all printed circuit board assemblies are not single-sided. In today's world of hybrid and mixed technologies, the PC board that is entirely flat or plain on one side is a rare creature indeed. Printed circuit board assemblies typically can carry heat sinks, connectors, jumpers, transformers, all on both sides of the substrate. These uneven surfaces to the board present an indirect path of heat conduction from the hot plate to the board assembly. A simple side-by-side comparison of a hot plate and the superior forced convection air bath reveals the many inherent advantages that the air bath brings to the benchtop technician. This illustration shows that while the hot plate provides an indirect and extremely slow transference of heat to the PCB, in fact what can take up to 12 minutes to preheat, can be done in as little as 3 minutes with a forced convection air bath. Still, hot plates do have their place in this world, just not with printed circuit boards. There are many drawbacks to infrared or IR preheating systems, which is probably why they never really caught on. These devices simply have too many limitations to be a truly universal preheating tool, as you will see. Preheating is a science that requires precision. Just as in high-volume production, the preheating phase of PCB processing is exact. First, the industry standard for the thermal ramp rate in preheating has long been established at 2 to 4 degrees C per second. The initial preheat ramp rate in the reflow profile that is typical in high-volume production is equally critical at the bench where prototyping and rework is performed, and quality assurance groups know that an excessive preheat ramp rate will cause thermal shock to chips, will cause popcorning of internal moisture within the component, will cause cracking or fissuring of ceramic capacitors, and cracking and fissuring of glass diodes. Most all IR preheating systems are dependent on technician guesswork, where a so-called power mode dial permits the technician to willy-nilly turn up the heat intensity without any thermal feedback or temperature reference whatsoever. Now, there are a few IR preheaters that provide a goofy digital display between 0 and 100% of power applied, but power of what? Wattage? Amperage? This gimmick does not correlate to any actual temperature applied to the PC board or to the thermal ramp rate whatsoever. Now, attempting to address the lack of true temperature control, some manufacturers of IR preheaters have recently introduced what they call a thermocouple mode, which is in truth a do-it-yourself temperature control method where a technician must make his own thermocouple and stick it somehow to the top of the PC board. And to shorten the time, here's an accelerated demonstration in fast motion of just how the do-it-yourself thermocouple mode attempt at temperature control works. So if you can finally get the thermocouple to stick to the PCB, where do you place it? How do you ensure repeatability from one technician to the next? And how does the top side relate to the bottom side of the PC board, where the temperature really should be controlled from, since that is the most vulnerable point? These IR preheaters, with either their so-called power modes or their do-it-yourself thermocouple modes, either have no temperature feedback whatsoever or non-repeatable, unreliable temperature feedback. Subject your PC boards to delamination, permanent board warpage, PCBs that are scorched or burned, and even accidental reflow of existing solder joints. Finally, other drawbacks of infrared preheaters include eye strain, fatigue from the intense glare from the IR source. Indeed, even a few minutes of IR glare can cause discomfort to the technician's eyes. And if your PC board happens to be small, the heat generated from these large IR heating grids is most unpleasant. And still, many infrared preheaters have problematic cold zones right smack in the middle of the heating grid, where one would naturally wish to center the PC board. In review, IR preheaters can lack critical thermal ramping, can require too much technician guesswork, can utilize either goofy power modes or do-it-yourself thermocouples, which are very difficult for technicians to repeat, and can have cold zones in the middle of the grid. And while there are still even more drawbacks to IR preheat, let's move on. We've now covered the first three methods of preheating PC boards at the bench: the convective oven, the hot plate, and infrared or IR preheaters, and we've discussed their various drawbacks and limitations. The fourth and final method is that of bottom side forced convection, also known as an air bath preheater. In the early 1990s, the now patented Zephyrtronics air baths introduced engineers and technicians around the globe to the world's first standalone temperature-controlled bottom-side preheating system. Because its forced convection mimicked the benefits of preheating PCBs with an oven, the air bath could deliver its preheat into all the nooks and crannies on the bottom side of a PCB, unlike a hot plate. With closed-loop sensing and thermal control built into the air bath preheater, your PCB can be ramped to temperature at the industry-recommended rate of a gentle 2 to 4 degrees C per second. No technician temperature guesswork, no do-it-yourself thermocoupling, preheat ramp and temperature control are built in. And just as all high-volume PCB conveyor ovens have a cool-down zone for stronger solder joints, so the Zephyrtronics air baths feature a quick PCB cool-down switch right at the front panel, and quick cool-down is mandatory for any BGA rework. It's little wonder now that the Zephyrtronics air baths were so widely acclaimed in the early 1990s, as they truly transformed the benchtop process, winning Best New Product at the Surface Mount International Expo in Silicon Valley, being hailed by SMT Magazine's editorial staff as innovative and a simpler, safer way to remove and repair sensitive devices. Indeed, recognizing its critical contribution to the electronic benchtop, NASA wrote that the Zephyrtronics air baths bathes the circuit board in warm air to reduce thermal stresses to the board and its components. From being spotlighted in the Definitive Tech surface mount technology to being approved by the testing labs at Motorola, Boeing, and Raytheon, to being recommended by National Semiconductor and International Rectifier, the Zephyrtronics air baths forced convection preheating is the first choice when it comes to preheating printed circuit boards.